Hi, welcome to the next installment of the behind the scenes for Ethereal Mechanics. We're in the garage now. I've been on vacation for the past 2 weeks, and I've been slowly getting the garage into shape. The garage is going to be the new workshop. I've installed an insulative ceiling so that I could heat the garage. Here is a 5 kilowatt garage heater, which is doing a good job keeping the garage at 62 degrees in spite of the fact that it's 16 degrees outside. I'm slowly getting all of the workbenches installed. All the workbenches are on wheels so they can be moved around. I'm still doing a lot of sorting of stuff. These are the Herky cabinets. They're causing a glare because they're made of stainless steel. They're very nice. I still have some missing parts, but the Herky is of the best garage cabinets you can get. They're not the flimsy ones you get from Home Depot or Lowe's, where the slightest bit of load in them they bend and topple. These are very well made, worth the cost. And I'm still using the garage for sorting some other stuff. There's still a lot of stuff to be sorted. I figure it's going to be another 2 months before we're starting to run experiments out here. Figure February we should start have our first set of experiments that will be running in the new workshop here. That's all for the garage for now. Here's my two best buddies, Terrence and Philip. That's Terrence. His nickname is Terrence the Terrible, but don't let him fool you. He's a big coward. Here's Philip. His nickname is Flip, because when you say Philip really fast, it sounds like you're saying flip. Philip is the boss around here. Even though he's a little guy, he's the actual boss. He will put Terrence in his place when he wants something that Terrence has. And Philip eats. He's got his own little dish on the counter so that the lower class can eat. That's where Terrence eats. So they're the cutest. They're my babies. They're in every room I'm in. They're in except they won't be with me in the garage when I'm out in the garage, because I don't want them getting anything dangerous. Very, very sweet cats. And other good news, I'm in remission. Just found that out a couple days ago. So I've been doing things now that I have time, a little more time maybe than I thought I had before. I decided it's worth the time to go through my integrated circuit collection and see what I have. There's some integrated circuits I inherited from my uncle, which are these guys. No idea what they were. He died almost 8 years ago. These, I find out, are high voltage, high power operational. They work in the area of 450 volts. And as I've said before, that to uncover some of the secrets of Ethereal Mechanics, we have to go into high voltage. And I'm already designing experiments to go into the tens of thousands and the hundreds of thousands of volts. But we can use lower voltage if we go higher frequency, and these can do 1 megahertz. And so we're definitely going to put these bad boys to use. I've also found some other interesting silicon from projects that I started 10 years ago and I abandoned for one reason or the other. So I got some other high voltage silicon standing around. So these will be put to use. On the Arduino front, this is the Arduino project that I'm working on called a Multistep, which is have multiple sensors. There's going to be more stuff up here. It's under development right now. I'm going to release all the software for it and all the schematics of all the interfaces. Basically over here there's going to be a 3 serial port networking scheme. You can network all these guys together, so in the laboratory I can have one doing inductance measurements, one doing, in other words, have all the experiments networked together so they can dump all their readings and data into a central computer, which it might be a Raspberry Pi. Right now the sensors I have are the MQ2 smoke sensor, the MQ7 carbon monoxide detector. You guys know what those are going to be for. Just an illumination sensor I picked up from Radio Shack, a microphone. This is going to be the humidity or barometric pressure sensor. I have a temperature and humidity sensor here, and I have a real time clock here so we can keep accurate time, which when this is installed will update the time here, which you may not be able to see from the glare because the screen's not as bright as the light, illumination light. And so this, I'll publish all this stuff for free, and this will become the basis of a lot of other experiments, like a precision inductance meter and some high voltage instrumentation that we're going to be developing for the experiments as we go forward. Other things in the news, The QAlgebra paper was rejected, and I know a lot of people out there are going to say, oh, there's big money interest that's repressing new ideas in science. No. And when it was rejected, they didn't even give a reason why. Usually they'll say, well, we're not the right publication, or we found a mistake, or you know, there was absolutely no word, no reason given. That's pretty strange. And the reason why people shouldn't be going around, I know there's a lot of OverUnity people. I don't believe in OverUnity, but I would love to be proven wrong. I would love, every engineer would love there to be an OverUnity device, because then we get rid of the power companies. Okay, but right now I don't subscribe to that. But that's okay. I'm okay to be proven wrong. But the one reason, if you do have an OverUnity device that works, don't go around saying that, oh, it's a big money interest or suppressing it, because you're shooting yourself in the foot, and here's why. Because what you are saying is, the only reason why somebody would want to suppress something is because they know it works. And the only way that they would know that it works is because they already have a working version, or have seen a working version somewhere else. Okay? And therefore, what you're saying by saying that big money interest is suppressing my idea, you're saying that somebody else already has it. Okay, so you might not want to go down that route. And I don't think big money would be suppressing ideas like that. And I don't really care. If you have an OverUnity device, I don't care what big money says. I'll buy it from you. I'll buy one if you can show me it actually working. And then other than my initial investment in purchasing it, it actually produces power. I'd be happy to buy one. I'd be happy to be proven wrong. So, you know, it doesn't really matter. If you have one that works, there's no reason why you can't produce them and sell them. It doesn't matter if scientists and engineers don't sign off on it, or if somebody's suppressing you. You know, when you sell one man to another. It has nothing to do with big money or anybody else. The reason why I'm not surprised that it's rejected is because, you know, journal reviewers are not the smartest tools in the tool shed. If you are a top-notch graduate and a good engineer, or a good scientist or physicist or mathematician, you're going to be producing the new ideas, not working for a journal reviewing them. Okay, I mean, the C&D students have to get jobs somewhere. Allowed to publish. And so if you're a person that really wants to publish other ideas of your own, you're not going to be working as a reviewer. And that depends on the publication. So why was it rejected? Well, again, because people that work for journals are not, their income is tied to the credibility of their publication. And so, you know, they're going to be very cautious about what they allow into the publication, because they're worried about the credibility. If they lose credibility, then the journal might go out of business and they're out of a job. So they have to maintain and protect what they believe is the credibility of a journal. So you're a nobody, and you send them a paper, and you're not associated with any university or anything like that. But you're only doing a small little delta to science. They might publish it. Like in the beginning of QAlgebra, I thought I was just going to provide division, which wasn't already there. I didn't realize until I got into it that I'd be showing that a lot of vector products that we currently have are invalid. Okay, now if you present that to somebody who's not the sharpest tool in the tool shed, they're going to say automatically you go to the smarter monkey theorem. Well, if that were true, somebody smarter than me would have said something by now. And we're going to have a whole new video on the smarter monkey theorem. I've actually turned it into a rule of acquisition. Okay, therefore, if like me, if they're going to take a no-name work that requires radical rethinking, and because they're not an expert in the field, they will reject it. And why are they going to do that? Because if it turns out that this no-name work is completely wrong, it's the journal that loses the credibility. It's the journal that takes the hit for it. Okay? And if you're the guy that was the reviewer and you allowed this to go into the paper, your bosses are going to say, hey, you've ruined the credibility of my journal. I'm going to fire your ass. So they're going to be very cautious, especially since they're not the brightest tools in the tool shed. They're going to be super cautious. Okay, but on the other hand, if a big name radical, let's say another Albert Einstein says, oh, we're going to radically rethink everything, they're automatically going to publish it in the journal, because they got to free out here, because if it turns out to be wrong, it's not the journal that takes the hit, it's Albert Einstein that gets the loss of credibility. So if you're a big name scientist or you're associated with a big name university and you got name behind you, you're more likely to get a radical work published in a journal than if you're like a nobody like me that does not have a university or a big name behind me. So that's typically the reason why things that are radical are not published in journals. And journals are kind of obsolete anyway. Journals were set up back in the old days to allow people of a specific interest group to communicate their ideas among the group. You know, if you have a scientist in the UK and a scientist in America and a scientist somewhere else in the world, and they're all working on some field, and this is like maybe the 1920s where basically all you have is limited telephone and radio. What they would do is they would set up one person with your university staff, and they'd all be sending their papers. They'd get published and pushed back. And this is when journals were small. They'd publish everything because it's a small crowd. As journals get bigger and the amount of space they can publish is limited and they get thousands of people that want to contribute, they've got to pick and choose. Okay, so you know, now with the internet, anybody can come up with a blog and put their stuff, and people can add to the blog, and it can be as free and open and has worldwide scope. So these old journals are obsolete by the internet anyway. The only good reason for journals right now is they're kind of a way to put your name, get basically a stamp on your idea that you invented it. And that was one of the reasons why, even though I was rejected, I still got that stamp that I submitted that paper to them, as well as a regular copyright. And perhaps in the future, I will resubmit to an engineering journal. So now that I have time, and more time than I thought I would have, I will spend time to do something like that. And lastly, let's talk about going ahead for Ethereal Mechanics. What you see here is how we're going to come up with the ethonic field equations, because we're never going to be able to touch ether directly. And Q algebra is completely rocking my world. In one of the videos about the latest Q algebra video, you're going to see the single equation that I'm working on that seems to give all the pretonic fields. But Q algebra, as applied to pretonic, may come up with multiple different answers to give the right answer. And each one of those would be one of the answers. Because as I said before, you have a few observations, and you can come up with a lot of different theories or models that fit the same observations. Okay, you shouldn't limit yourself to one. That's where science gets their big mistake. They get the first one that fits the dots, and they say, oh, well, that's got to be right, everybody else is wrong. And that's where science holds itself. So we're going to come up with as many Q algebraic pretonic equations that fit the observed data. And each one of these lines represents one of those equations. We're going to have to do the same thing with the pretonic electron model. The model we're using now is a new electromagnetism, which is just a gateway model. We need to come up with a better model that, using the pretonic equations, that is, are able to give all of the properties of the electron as close as possible. And we may come up with different ways that pretons could move in an electronic model to give all the observable answers. There may be more than one solution. Okay, again, then we're going to go to the macroscope. What are the macroscopic ether models? These are the models that we developed based on gravity and ether flow and all the things like that. The only thing that we're really missing right now is a density function and a realistic ether viscosity constant. So I'd say this is like 90% done because of that. This is ether at the large scale level, not down at the pretonic level. This is at the scale of planets and stars. Okay, and then then we're going to come up with we have to come up with new wave equations. The wave equations currently published are very crude approximations. We have to get down and dirty with the details about waves, and we're going to study all kinds of waves and show you that there's properties of waves that are being ignored. And we're going to show you how polarizers work and how a lot of different things work, and develop new wave equations using Q algebra. Okay, where all of these things intersect is going to be, hopefully there's only one place they intersect, and that is going to be our ethonic equations. One set of ethonic equations needs to explain all of these things. These are like the boundary conditions. Mathematicians and engineers understand boundary conditions. Okay, now there might be another set that's pretty close that we may want to consider. We may have to come up with a fifth element and have another set of intersections to distinguish or disambiguate one from the other. Okay, so that's our path forward. I still have a lot of work to go here. Q algebra is still evolving. Looking at the fourth dimension now, there's interesting effects in the fourth dimension I don't understand yet. I need to get that understood before we can pretty much lock anything down. The pretonic electron model is still up in the air. There's still some things I haven't worked out yet. But hopefully when I get this squared away, this will get squared away. These together have to predict all of the electronic field equations or new electromagnetism. So this is the boundary condition for these two. Okay, so you see we got a lot of work to go here. A while ago I thought I had everything near a very close endpoint. I only had one thing that was giving me trouble, but that is all nebulous now because Q algebra has just opened up a whole new can of worms. And so you're where I am. I only got some little bit ahead of where we are with the videos right now. I want to keep ahead of the videos. I want to be sure where we're going before I do the videos because I don't want to have too many errata videos published. So we're going to have one errata video that's going to be up in a little while, but 3 things that need to be corrected so we can go forward. Anyway, that's what I have for now. Thank you.